How many moles of carbon dioxide are there in 300.0 milliliters of 0.90 molar CO2 solution? First things first, let's figure out what we've been given. We have 300 milliliters, 300.0 milliliters of solution. That is 0.90 molar in carbon dioxide. Anytime I see a concentration unit, my first instinct is to dissociate that concentration unit into its units. So that 0.090 molar carbon dioxide solution becomes 0.90 moles of carbon dioxide per 1 liter of solution. By separating the concentration unit into its components, you can see that the concentration unit actually consists of two different units, an amount and a volume. Whereas the 300.0 milliliters of solution consists of only one type of unit. When performing a mathematical calculation, it is always ideal to begin with a value that has only one unit associated with it. And so we're going to begin this calculation with a 300.0 milliliters of solution and convert that into moles of CO2. So starting our calculation, we have 300.0 milliliters of solution. Now, because we want to travel between a volume of solution and a moles of the solute, we're going to need to use our concentration unit. So we will want to use the 0.90 moles of carbon dioxide over 1 liter of solution. But in order to use this concentration unit, our volume must be in liters. So the first thing we need to do is actually convert this milliliters into liters. There's 1,000 milliliters of solution in 1 liter of solution. The 1,000 milliliters were placed in the denominator so that the unit and the substance would cancel, leaving liters of solution for the numerator. Now we have it down to the concentration unit. And since our volume is in the same unit as what appears in the concentration unit, we are now ready to use our concentration conversion factor. The 1 liter of solution is placed in the denominator so that the unit and the substance will cancel out, leaving the 0.90 moles of CO2 to go into the numerator. Because all of the units have canceled out except the moles of CO2, and moles of CO2 is what you were wanting to find, we are ready to begin this calculation. So 300 divided by 1,000 times 0.9 gives us 270,000 moles of CO2. And that is incorrect. It did not look correct, and I did not key it in correctly. So let's try this again. 300 divided by 1,000 times 0.9 means you have 0.27 moles of CO2. Now this is multiplication and division. According to the rules of multiplication and division, your answer will have the same number of significant digits as the measurement with the fewest. 300.0 has 4 significant digits because zeros at the end of the number after the decimal are significant. The 1 liter of solution for the metric prefix conversion is an exact number, and therefore it has an unlimited number of significant digits. The 1,000 milliliters is also an exact number, and therefore has an unlimited number of significant digits. The 0.90 moles of CO2 from the concentration unit has 2 significant digits because zeros at the end of the number after the decimal are significant. And the 1 liter of solution from the molarity is an exact number, and therefore it has an unlimited number of significant digits. So you have 4 significant digits times an unlimited number of significant digits divided by an unlimited number of significant digits times 2 significant digits divided by an unlimited number of significant digits. Since the measurement with fewest had 2 significant digits, our answer can only have 2 significant digits, and so we would record it as 0.27 moles of CO2. Folks, one of the things you would have noticed again is that I checked my work to see if it made sense. And 300 divided by 1,000 is 0.3. So I knew that it did not make sense for me to get 270,000. You should always glance back to see if you're on the right track with your calculations.